Dear staff and students, today we are going to take on the topic of fiber optic communication. So before we enter into the subject, what is the fiber optics? Where the terms will come from? The fiber optics, it is a branch of physics which deals with the transmission and reception of light waves. Transmission and reception of light waves. Here, light will act as a guiding medium. Light will act as a guiding medium. And another question will arise when you are utilizing the light waves. So normally we are using the radio waves as well as microwave for the communication purpose. Then why we are go for light waves? Because as we look at into the frequency of the microwave as well as radio wave, here radio wave having the frequency of 10 to the 6 hertz. So here microwave is 10 to the 10 hertz, but light wave having 10 to the minus 15 hertz. So here the frequency is very higher when compared to the other, so that we can accommodate more data when compared to the other two waves. Next, this is the optical fiber, which consists of core, cladding, and then stretching material, and then outer jacket. So this is the structure of the optical fiber. So here it is a graph. It is a graph drawn for the material along x-axis and refractive index along the y-axis. The refractive index, we are looking at core having higher when compared to the cladding and air. The refractive index of the air is always equal to 1. The refractive index of the air is always equal to 1. The cladding and the core having refractive index is depending upon the material what we are choosing. So basic thing is, if we consider an optical fiber, the refractive index of the core should be greater. Cladding should be smaller, so that only in the picture represent it will shows.
Start.
So next we are going to discuss about the advantages of optical fiber when compared to the ordinary fiber. So first thing is, it is light in weight. Weight of the cable is very less, as well as it is smaller in size and easily flexible, and it can able to bend at any position. Size is very small, we can able to bend, as well as it should be flexible when compared to the ordinary cable. So it is a non-conductive and non-radiative and non-inductive, because light is alone only is passing to the core. There is no electrical supplies used, so that it should not be, or it cannot be conductive material, or non-radiative or non-inductive. It also having high bandwidth. I already told that light wave having 10 to the 15 hertz, so that it can capable of having high bandwidth. And there is no short circuiting, because we are using only the light as a carrier medium. We are not using electrical power supply, so that there is no possibility of short circuiting. And also there is no internal noise. As well as it can withstand very high temperature and moisture conditions, because it is core, cladding is there, it is supported by the stretching material and outer jacket, so that it can withstand to the very high temperature. So after that, we are going to deal about the principle. What is the principle behind the optical fiber? The optical fiber is worked based on the principle of total internal reflection. Once the ray of light is enter into the core, what will happen? It will make total internal reflection. It will reflected on the core. Once again it will reflect on the core. Another time reflect on the core. So that only we can able to give the input here, and then the same output is coming out there. It is input and output. This is the principle. The principle of optical fiber communication is total internal reflection. This is the principle behind the optical fiber. So now we are going to discuss about the various types of optical fiber materials. Optical fiber materials, both are same only. So based on that material, number of mode and refractive index profile, the optical fiber can be classified into three types. First one is material, number of modes and refractive index profile. Based on the material, it is classified into two: glass fiber and plastic fiber. Most probably the glass fiber is always made by using the silicon oxide. Silicon oxide is the main source, silicon dioxide, and the cladium is made by the silicon oxide doped with phosphorus oxide or whatever may be. Here is the glass fiber. And the plastic fiber, the name itself, it shows that the plastic fiber is made up of plastics. So normally the core, already I told that optical fiber consists of core as well as cladding. The core is made up of the polymethyl methacrylate and the cladding is copolymer, so both are plastics. So by using that we can able to pass or transmit the signal from one place to the another place. Another type is number of mode. So based on the number of mode, it is classified into two. One is single mode fiber, another one is multi-mode fiber. And the refractive index profile, step index fiber, another one is gradient index fiber. So now we are going to talk on materials. Glass fiber we have studied, plastic fiber we studied. Now we are going to study on the number of mode, single mode fiber and multi-mode fiber. So here it is the pictorial representation of single mode fiber. Here look at that, the center dot in black color, it is the diameter. So diameter, it is a core followed by the cladding. Another one is the primary coating, it is the outer jacket, or we can say that buffer. Okay, here we look at that the refractive of the core. We can look at that refractive of the core is very small, but when compared to the cladding, here is the cladding, no, here is the cladding. Here the diameter is very large. So the diameter of the core is very small, so that it can propagate only single mode. It will propagate only single mode fiber, so that only it is named as single mode fiber. It will transmit, or it can able to transmit and receive only one mode. It is so that it named as single mode fiber. Next we teach about the multi-mode fiber. The reverse of the single mode is nothing but as a multi-mode fiber. So here the diameter of the core is very large. You look at the diagram here, the black dot is very large. So this is the core. This is the core. It is very large. The cladding diameter is very small. And look at the image. So N1 is larger. So N1 is nothing but as refractness of the core. N2 is nothing but as refractness of the cladding. So it allows multi-mode of propagation. Due to the diameter of the core is large, it allows multi-mode of vibration. So it is called as multi-mode fibers.
Start.
Now we are going to see the difference between the single mode and multi-mode fiber. The single mode fiber can able to propagate one mode due to the diameter of the core is small.
Start.
So in multi-mode fiber, it allow many number of modes because the diameter of the core is very large. So here already we say that the single mode fiber, the diameter is small, and also in multi-mode fiber the diameter of the core is very large.
Start.
Here no dispersion will take place, but here the dispersion will take place. We don't know the reason, because the diameter core is small, so there is no probability of dispersion takes place. Here the diameter of the core is large, so the dispersion will takes place. As well as launching of light and connecting to fiber is difficult due to the core diameter. So here launching of light and connecting to fiber is easy due to the large in the diameter of the core. And also the fabrication manufacture is very difficult. Manufacturing is very difficult, as well as installation is also very difficult in case of single mode fiber. But in multi-mode fiber, fabrication is very easy because the diameter of the core is large, so that we can able to easily fabricate, and installation cost is low. This is the difference between the single mode as well as multi-mode fiber.